In this clip, I'm going to review the Pythagorean identities and two of the double angle identities that are seen often in our calculus book. We're going to start with the Pythagorean identities. There are three of them. The first one is sine squared plus cosine squared equals 1. And most students probably have this committed to memory from their trig class. The other two are maybe a little harder to get, but I've got a little bit of a trick. If we take the first one and we divide each term by cosine squared, we end up getting tangent squared plus 1 equals secant squared. So this is number 2. This is number 1. And then the third one is just the co of the second one. So tangent squared becomes cotangent squared, and secant squared becomes cosecant squared. So here are the three Pythagorean identities in no particular order. Now for the double angle identities, the first one you really just have to memorize. It is 2 sine theta cosine theta. And then cosine 2 theta, there are actually three variations. The first of which is cosine squared theta minus sine squared theta. Now it looks a little bit like this one, but they're not the same. I mean, one is a plus and the other one is a minus. So just be very careful not to confuse those. Those are not equal. Now notice that the letter C comes before the letter S in the alphabet. We can find the other two by using Pythagorean substitution. So the first variation is going to be 2 cosine squared theta minus 1. And then the other one is 1 minus 2 sine squared theta. So for each of these, there's a first position and a second position. And the C always is in the first position, whether it's here or here, and the S is always in the second position. And that just helps me to distinguish between them. Hopefully it'll help you too. So here are two examples that use these identities. The first, it says evaluate 1 minus 2 sine squared 5 pi over 6. Now this is looking a lot like this guy right here. So the theta is 5 pi over 6. And the formula is cosine of twice that theta. So this is the same as the cosine of twice that particular theta. Now if I double 5 pi over 6, I end up getting 5 pi over 3, or 300 degrees, which is in quadrant 4, where cosine is positive. So the answer here is 1/2. In our second example, we see trig identities in the context of an equation. So I'm first going to focus my attention here, and I have to replace this with something. Now, because it's the cosine double angle identity, I've got three choices. And I want to pick the choice that's going to work the best with this. So I want to stick in a uniform trig family, so I'm going to pick the second one here, because that's entirely cosine. So I'm going to replace cosine 2 alpha with 2 cosine squared alpha minus 1 equals cosine alpha. I'm going to move everything to one side. 2 cosine squared alpha minus cosine alpha minus 1 equals 0. I'm going to factor this. The factors of 2 cosine squared alpha are going to be 2 cosine alpha, and cosine alpha. And the factors of 1 are 1 and 1. And this is going to be minus, and this is going to be plus. Setting each of these factors equal to 0, I get cosine alpha is equal to -1/2. And then over here, I get cosine of alpha is equal to 1. Now, cosine is equal to 1 at 0 radians. And cosine is negative in quadrants 2 and 3 with a reference angle of pi over 3. So we have 2 pi over 3 and we have 4 pi over 3. So this particular equation has 3 solutions on the interval from 0 to 2 pi. And here they are. At this time, you should go on to do the problems associated with clip number 11.